Okay. Till the first meet, we have discussed about the tension members. Okay, we have discussed about the tension members and how to design the tension members that we have discussed. And another topic regarding the tension members is tension member splice. Okay, tension member splice. Splice means a small piece of steel. Okay, small piece of steel which is used to attach the two steel members. Okay, a small piece of steel which is used to attach two main steel members, that is known as splice. Okay, so we have already discussed that steel members are manufactured in the industry up to 40 feet. Okay, so what if we require more than that? Okay, length required is more than that. What we have to do? We have to join the two members by using some common portion. Okay, so here we are joining. See, this is a member and this is a member. So these two members are joined by using a single piece of steel. Okay, so in order to provide the good connection between two members, we are using a single piece of steel to join two members. Okay, so that piece of steel that we are using to join another two members is known as splice. Okay, splice. If it is a tension member, if you are using it in a tension member, then it is known as the tension splice. Okay, so see here is the I section. You can see in the diagram. Here is the I section. Two I sections we are joining here. Okay, so without using this splice, if we join these two I sections, the connection may not be good. ఓకే ఎందుకు కామన్ గా ఏది ఉండదు కామన్ మెంబర్ ఏది ఉండదు కాబట్టి కనెక్షన్ అన్నది సరిగ్గా ఉండదు సో వీఆర్ యూజింగ్ ఏ కామన్ స్టీల్ మెంబర్ టు జాయిన్ దీస్ టూ splices, sorry, these two members. Okay, so this piece of steel is known as splice. Okay, so this splice may be connected by using welded connection or bolted connection. Okay, both bolted connection and welded connections are used in order to join these two members. So here you can see the bolted connections. Okay, and two I section members are joined by using the splice and bolted members. So the red portion undi kada, red portion of this steel member is the splice, means that is the external member that we are using to attach the two I section here. Okay, so that is the tension splice. Okay, so we may we may use we may use welded connection and bolted connection both. Okay, so coming to the tension splice, so we have already discussed that tension splice. Okay, so this tension splice may be provided either one side of the joint or both sides of the joint. Okay, wait. Okay, so this tension splice may be provided either one side of the joint or two sides of the joint. Okay, if tension splice is provided only one side of the joint, means single cover lap joint, like that. If we provide single cover lap joint, what happens? Due to the single cover lap joint, eccentricity may develop during the passing of the loads. Eccentricity may develop. So in order to avoid the eccentricity, we have to provide splices on both sides of the plates. Okay, main plates. Okay, means we have to provide the double cover lap joint. Okay, double cover lap joint. Okay, what happens if single cover lap joint is provided? Eccentricity may develop. As if eccentricity develops, bending moment may develop. So it is very hard to control the bending moment. So we are using the splices, tension splices on both sides of the joint. Okay, so in this criteria, this is a plate and this is a plate. Okay, idi oka plate, idi oka plate. So these two are just plates. So we have used the to another splices and joined by using the bolted connections. Okay, so here come to the second diagram. Here two angle sections are we are joining here. Okay, two angle sections are joining. So while joining the angle sections, okay, there will be web and flange. Okay, angle section ante enti nothing but L section. L section lo web untundi, flange untundi. So only just by using this type of tension splices, we cannot join the angle section. Okay, we have to provide a tension splice here, we have to provide tension splice here, and we have to provide the tension splice on the top also. Okay, means by using the angle section on one side and by using two tension splices on other side, we have to join the angles. Okay, so tension splice means always it doesn't mean it is a horizontal steel member. Okay, if based on the main members, based on the shape of the main members, we have to select the shape of the tension splice. Okay, so simply a tension splice is a external member that we are using to join the two main members. Okay, so come to the third case. In this case, we are joining two members of different thickness. Okay, in the third case, we are joining two members of different thickness. So if we want to join the members of two different thickness, different thickness ఉన్నప్పుడు ఏంటి, in order to provide the good connection, we have to provide a packing plate here. Okay, we have to provide a packing plate here. So packing plate means ఇది ఒక థిక్నెస్ ఉంటుంది, ఫస్ట్ ప్లేట్ ఒక థిక్నెస్, సెకండ్ ప్లేట్ ఒక థిక్నెస్ ఉంది. సో రెండు డిఫరెంట్ థిక్నెస్ ఉన్నప్పుడు ఏంటి, ఇక్కడ స్పేస్ అన్నది వస్తుంది. So in order to cover that space, we are using the packing plate. Okay, if there is space and we are making the joint like that only, what happens, that connection may be loosened. Okay, but we have to provide the packing plate. Okay, so this is the third type. Okay, first type, second type, and third type. In the first type, what we are doing, only two, I mean, not the types, these are the cases, different cases that we experience while providing the tension splice. Okay, the first case we are just joining two plates, so no problem, we will provide a double cover butt joint and join the two plates. Okay, and in the second case, we are joining two angle sections. Okay, two angle sections. Angle section means there will be flange and web. If flange and web untundi kabatti, we have to provide the connection for flange and both for web also on either side. So that is another criteria. And third one is using the packing, when the thickness of members to be connected or different. Okay, so these three types we may experience while solving the tension splice problems. Okay, so see, strength of the splice plates, okay, comma connections must equal to the design loads. Okay, while we are designing a tension splice designing means we have to decide the thickness of the splice plate. Okay, tension splice thickness, sorry, wait. Okay, design of tension splice includes we have to find out the thickness of the splice plate. Okay, so when we will find out the thickness of the splice plate, okay, thickness of this splice plate again depends on the what is the load coming to the members. Okay, so while designing the tension splice, what is the strength we have to provide for the splice plates, and connections must be equal to the design load. Based on the design load, we have to decide the thickness of the splice, and we have to design the connections. Okay, what is the if it is the welded connections, based on the design load, we have to decide the length of connection. If it is if we are providing the bolted connections, based on the design load, we have to decide the number of bolts to be provided. Okay, so based on the design load only, we have to decide the thickness of this splice plate and connection. Okay, connection includes number of bolts and what is the length of welding if welding is provided. Okay, so that is a design of tension splice includes. Okay. Now, see. Okay. So design of tension splices. Design of tension splices is same as design of tension member only. So design of tension member మనం ఎలా చేస్తామో సేమ్ అలాగే design of tension splices కూడా. Okay. But in the previous point only we have discussed connections or thickness of tension splice must be equal to the design load. Strength of those will equal to the design load. So here, what is the extra thing we have to add is we have to first design the connection. Okay. Design of tension members lo manam em chesamu, just 3 cases check chesi what is the design load, what is the strength of that member that we have given. But here, while designing the tension splices, we have to design the connection as well as the thickness of the splice plate, right? We have to decide the connection and thickness of the splice plate. Okay, kabatti two things we have to design here. One, design of connection and design of the splice plate. Okay, so okay, these two steps will include here in the design of splices. Okay, so coming to the third case enti, while we are using the packing plate. Okay, packing plate use chestunnam ante we have to consider the reduction factor of beta pk, that is equals to 1 minus 0.0125 tpk, where tpk is the thickness of packing plate. Okay, so packing plate, we are using the packing plate as extra. Okay, so due to the use of that packing plate, the shear carrying capacity of the connection may reduce. Okay, so that also we already discussed. Okay, enduku whole ga unnappudu shear carrying capacity okati untundi, but ikkada manam packing plate use chestunnam kabatti adi whole ga undadu annamata, two parts ga divide ayindi kabatti shear carrying capacity taggipotundi. Okay, so shear తగ్గిపోతుంది కాబట్టి we have to reduce the shear carrying capacity. Okay, up to which factor we have to reduce the shear carrying capacity? Up to beta pk. Okay, beta pk is equals to 1 minus 0.0125 tpk, where tpk is the thickness of the packing plate. Okay, and while designing, we have to consider one more point. As per IS specification, the splice connection should be designed for a force of at least 0.3 times the member design capacity in tension or the design action, whichever is more. Okay, so connection at to which load we have to design the connection? At least of 0.3 TD or T, means okay, TDD means design load. Okay, and T means what is the load acting on the member, what is the load acting on these members, that is the T. Okay, TD means design load. Okay, so what is the load we have to consider while designing the tension splice? Least of these two. Okay, 0.3 into TD or T. Least of these two we have to, sorry, more, which is more, that we have to consider. Okay, so which is giving the more load, that we have to consider among these two, 0.3D and T. Okay, so this is about the design of tension splice. So design of connection we have already discussed, either bolted or welded, that we have already discussed, and how to find out the strength of a tension plate, that also we have already discussed. Just discuss a problem on this. So this is a design a splice to connect 300 into 20 mm plate with a 300 into 10 mm plate The design load is 500 kilonewtons. Use M20 black bolts fabricated in shop. Okay, so this is the given problem. So what we have to design? Design the splice to connect. Okay, splice to connect 300 into 20 mm plate with a 300 into 10 mm plate. The design load is given as 500 kilonewtons and one plate is of size, first plate is of size 300 into 20 mm and another plate is of size 300 into 10 mm. Okay, and which type of bolts we have to use? M20 bolts. You are using M20 bolts means what is the diameter of the bolt? If you are using M20 bolts means what is the diameter of the bolt?
22, ma'am.
What is the diameter of bolt? Not diameter of hole. Diameter of bolt is 20. Okay. And black bolts fabricated in shop. Okay, fabricated in shop. Okay, so shop annar kabatti we have to take the safety factor according to the manufacturing type. Okay, and to find design the splice thickness of the splice plate we have to design. Okay, okay, and this, see, coming to the solution. Coming to the solution, see step 1. So first find out the strength of the connection. Okay, so manam plate thickness okati vaste saripodhu kada, we have to find out the strength of the connection also. Okay, so what is the strength of connection? Again depends on strength of bolt in shear and strength of bolt in bearing. Okay, which is the least of this, we have to take it as a strength of the connection. ఇది మనం bolted connections లో చేసాం already. Strength of bolt in shear and strength of bolt in bearing find out చేసి which is the least, that is nothing but the strength of the connection. Okay, so strength of bolt in shear, again we have to find out the strength of bolt in shear. So what is the formula for strength of bolt in shear? Beta pk is equal that is equals to beta pk into fub by gamma ml m1 root 3 into NNANB plus NSASB. Okay, this is the formula. Beta pk enduku use chesamu? One plate is of thickness 20 mm and another plate is of thickness 10 mm. ఒక ప్లేట్ థిక్నెస్ ఏమో 20 mm ఉంది, ఒక ప్లేట్ థిక్నెస్ ఏమో 10 mm ఉంది. అంటే we have to use the packing plate which is greater than 6 mm thickness. Okay, greater than packing plate, if packing plate is of greater than 6 mm thickness, then we have to consider beta pk. Okay, so here we are using the packing plate of thickness. What is the thickness of the packing plate we have to use? What is the thickness of packing plate that we have to use here? One plate thickness is 20 mm, another plate thickness is 10 mm. Then what is the thickness of packing plate?
10 mm.
10 mm. Okay, so thickness of packing plate is 10 mm, which is greater than 6 mm. So packing plate thickness is 6 mm kana greater ga unte, we have to consider the reduction factor beta pk. Okay, so strength of bolt in shear ki manam beta pk multiply chesam ikkada ante. Okay, so beta pk multiplied by fub by gamma m1 into root 3 NNANB plus NSASB. Okay, so beta pk, just find out the beta pk. Beta pk, I have given the formula for beta pk 1 minus 0.0125 into tpk. Okay, where tpk means thickness of the packing plate, that is nothing but 10 mm. So we can get beta pk as 0.875. Okay, okay, now find out the strength in shear. Strength in shear, substitute all the values in the formula. So beta pk is 0.875 multiplied by Okay. Okay. Beta pk is 0.875. Okay. So, and NN A and B, NS A S B. What is NN and A and B? What is NN and NS? NN means what, ma?
Number of shear planes.
Number of shear planes, huh? And then here is number of bolts which are intersecting with the threads and without threads. Ante kada? Okay. NN and NS are what? Number of bolts which are intersecting with the threads and without threads. Okay. So NN means 0.78 into pi by 4. Sorry, pi by 4 d square. A and B means pi by 4 d square. 0.78 into pi by 4 d square. So, ikkada number of bolts, we don't know number of bolts. So, just consider for one bolt. Okay. And plus here also consider for one bolt only. Okay. So, ASB means nothing but area of the shank. Okay. So, pi by 4 into d square multiplied by FUB is 400 divided by root 3 into gamma m1 is 1.25. Okay, so just say we can get the strength in shear as 90.4 kilonewtons. Okay. Okay, and again we have to find out the strength in bearing. Okay, strength in bearing, for to find out the strength in bearing, what is the formula? 2.5 kb d into t into fu, okay, by gamma mb. Okay, so here the unknown term is kb, and you have you already know that kb is the smaller of 3 e by 3 d naught comma p by 3 d naught minus 0.25 comma fub by fu or 1. So least of all these four we have to consider as a kb value. Okay, so for that we don't know the e value. I mean edge distance tellu, pitch tellu. So just assume that edge distance is 40 mm and pitch is 60 mm. Okay, I'm assuming. We don't know the edge distance and pitch distance. So just assuming that edge distance is 40 mm and pitch distance is 60 mm. Okay, so apply those in all these formulas and you will get kb value as 0.606. Okay, and substituting kb value you can get a strength in bearing as 99384 newtons. Okay, so what is the bolt value we have to consider? Strength of bolt is nothing but least of strength in shear and strength in bearing, which is the least 190.4 kilonewtons. So bolt value or strength of bolt is nothing but 90.4 kilonewtons. Okay, so we got the bolt value. Ante connection strength connection strength ఎంత ఉంది 90.4 kilonewtons ఉంది. So what number of bolts required? We have to find out the number of bolts required because number of bolts is not given, right? So connection, if you want to design the connection, we have to decide the number of bolts to be provided, right? So we got the bolt value, means strength of the bolt we got. So this is the strength of one bolt and the incoming load is 500 kilonewtons. Okay, this is the strength of one bolt and the load coming is 500 kilonewtons. So number of bolts required will be total strength divided by strength of bolts. If we do the total strength divided by strength of a bolt, then we will get the number of bolts. Ante kada? So 6 apples vachesi 60 rupees ante, sorry, 1 apple 10 rupees ante Okay, so this is the total load coming onto the connection, and this is the strength of 1 volt. Okay, so 1 volt ki 90.4 kilonewtons bear chestundi. So inta load 500 kilonewtons bear cheyali ante what is the number of volts we have to provide? Okay, so if we divide this, we can get 5.53. 5.53 volt provide cheyalem kabatti near ga higher value తీసుకుంటాం, lower value తీసుకోకూడదు. Okay, so round it off to 6 volts. 5.53 volts provide చేస్తామా? లేదు కదా. So round it off to 6 volts. So in order to satisfy this load 500 kilonewtons, we have to provide 6 volts for this connection. Okay, we have to provide 6 volts for this connection. So this is what we have decided, means connection we have designed. Okay, and we have to check whether it is good for tension strength or not. Okay, whether the connection that we have designed is good in tension or not, that we have to check now. Okay, so checking includes, again we have to find out the strength of the plates. Strength of the plates. So strength of the tension plate is nothing but strength against yielding of cross section, strength against rupture, strength against block shear. Okay, so strength of the plate depends, strength of tension plate will depend on all these three. So we ఈ 3 కూడా మనం find out చేయాలి. Okay, so ఈ 3 find out చేసిన strengths అన్ని కూడా greater than 500 kilonewtons ఉంటే, upcoming load 500 kilonewtons అంటే ఈ strengths అన్ని కూడా greater than 500 kilonewtons ఉంటే, then the design, then the connection we have designed is a safer one. Okay, okay, so what is the strength against yielding of cross section? TDC is equals to AG into Fi by gamma m naught. ఈ ప్రొసీజర్ అంతా కూడా మనం ఆల్రెడీ చేసాము, కాకపోతే ఫస్ట్ ఇంతవరకు ఈ ఫస్ట్ హాఫ్ అంతా కూడా వోల్టేజ్ కనెక్షన్స్ డిజైన్ లో చేసాము, సెకండ్ హాఫ్ అంతా కూడా టెన్షన్ మెంబర్ డిజైన్ లో చేసాము. ఇక్కడ మనం రెండు కంబైన్ చేస్తున్నాం. ఎందుకు? ఆ కనెక్షన్ ని డిజైన్ చేస్తున్నాం. ఇక్కడ మనం టెన్షన్ మెంబర్స్ లో ఉన్న కనెక్షన్ దట్ we are designing, so we are checking for that. Okay, so we have designed a connection, and we are checking whether the connection is good for bearing the tension strength or not, that we are checking. Okay, so in order to check that, we have to check all these three conditions. In all these three conditions, if it is safer, the connection is safer, then it is good to go. Okay, so what is the strength against yielding of cross section? TDG, that is equals to AG into Fi by gamma m naught. Okay, so AG means gross area. Gross area means 300 is the breadth, and thickness is 20 for one plate and 10 for one plate. So least of these two we have to consider. Enduku first fail edavtundi, least one will fit. So which one has the least thickness? 10. Okay, 10 mm is the least thickness. Least consider cheste emotundi, it will be the safer. Ippudu manam highest value consider chesamu ante load value varaku reach avvali. Okay, ఆ వాల్యూ వరకు రీచ్ అయ్యేలోపే మనకు ఈ మెంబర్ అన్నది ఫెయిల్ అయిపోతుంది, కాబట్టి లీస్ట్ వన్ వీ హ్యావ్ టు కన్సిడర్. ఓకే, సో AG 300 into 10 into Fi is 250, we know that. Okay, divided by gamma m naught is 1.1. Okay, so if we calculate this, we will get 681818 newtons, which is greater than 5000 newtons. So it is safer. Okay, means the connection is safer in yielding of cross section. Enduku yielding of cross section yield avvali ante inni newtons load annadi, I mean ఆ మెంబర్స్ మీద ఇంపోజ్ అవ్వాలి. కానీ మనకి ఇంపోజ్ అయ్యే లోడ్ ఎంత? 50,000 న్యూటన్స్ మాత్రమే. కాబట్టి the connection is safe against yielding of cross section. Okay, and strength against rupture we have to find out. Okay, that is nothing but TDN, that is equals to 0.9 AN/FU by gamma ml. Okay, so AN means net area. Okay, net area 300 net area, wait,